Hi, I'm George Woodbury from the College of the Sequoias in Visalia, California, and in this video we'll go over how to solve rational equations. A rational equation is an equation that has variables in denominators. In this equation we have 4x plus 3 over 4 minus 2x over x plus 1 equals x. The first step to solving this type of equation is to clear the equation of fractions by multiplying both sides of the equation by the least common multiple, or LCM, of those denominators. And here, that least common multiple is going to be the product of the two denominators, 4 times x plus 1. Now we have to make sure that any solution that we have doesn't cause a denominator to be 0. And what we can do is just check that least common multiple, make sure that we list the values that cause it to equal 0. 4, the first denominator, could never equal 0. But x plus 1 could equal 0 for a particular value of x. So what we want to solve is the equation x plus 1 equals 0. What makes that factor equal to 0? And if you subtract 1 from both sides, you would see that it would be x equals negative 1. This solution has to be omitted. So if we're going to come up with an equivalent equation, if negative 1 is a solution of that equation, we have to discard that. That's called an extraneous root. It's a solution that works in our new equation, but not in the original one. All right, so I want to multiply all terms on both sides by this least common multiple. So 4 times x plus 1 times the first fraction minus 4 times x plus 1 times the second fraction equals 4 times x plus 1 times x, what was already on the right-hand side. Now we want to simplify both sides. On the left-hand side, that first fraction, we can divide out the common factor of 4, and that leaves us x plus 1 times 4x plus 3, which we should go ahead and multiply out now. Distribute through the x first. X times 4x is 4x squared. X times 3, that's plus 3x. Now distribute through the 1, and that's plus 4x and plus 3. In the second product, I can divide out the x plus 1 factors, and I'm left with negative 4 times 2x, that's minus 8x. On the right-hand side, there's no denominators to divide out, so I just need to multiply this out. And I've got three factors, 4, x plus 1, and x. I can take 4x and treat it as one factor and distribute that through. So 4x times x, that is 4x squared, and 4x times 1, that is plus 4x. So this looks like a quadratic equation, but what we're going to see in a moment is that when we subtract 4x squared from both sides to get all those terms together, there will be no more squared terms left, and then it's going to be a linear equation. Anyway, we should simplify both sides first. The left side becomes 4x squared minus x, because 3x plus 4x is 7x, but then minus 8x is minus 1x, plus the constant term of 3 equals 4x squared plus 4x. Now, with a quadratic equation like this appears to be, we want to try to collect all the variable terms on one side, so I can subtract 4x squared from both sides, but at that point, again, those are going to be gone. I'm left with negative x plus 3 equals 4x. I can solve this by collecting all the variable terms on the right, add x to both sides. That gets me to 3 equals 5x, which I can then solve by dividing both sides of the equation by 5. And I'm left with x equals 3/5. Now at this point, you could go back and try to determine if that made any denominator 0, but I have already listed the solutions that I would have to exclude. Since I didn't see negative 1 as a solution, that solution must be good, and I'm going to put that in the solution set, 3/5. Let's take a look at a second one that becomes a little more involved than this one does. Solve 3 over x minus 2 plus 1 over x plus 2 equals x squared minus 4. The first thing I'm going to do here is factor the denominator on the right-hand side so that I can figure out what is the LCM. And here, x squared minus 4 factors to be x plus 2 times x minus 2. That is the LCM here. So when I'm finding the LCM, I try to take the first denominator I see and I write it down. So I see an x minus 2. Then I go to the next denominator and I'm looking for factors that aren't already in my LCM. And x plus 2 is one of those. Then I go to the next denominator and x plus 2 and x minus 2 are already accounted for in my LCM, so I don't need to write them a second time. That is my LCM. X minus 2 tells me that x cannot be equal to positive 2, and the factor of x plus 2 tells me that x cannot be equal to negative 2 as a solution. Right. Next step, I want to multiply through by the LCM. Let's write that out. X minus 2 times x plus 2 times 3 over x minus 2 plus x minus 2 times x plus 2 times 1 over x plus 2 equals x minus 2 times x plus 2 times 12 over x plus 2 x minus 2. That takes up a lot of room. Your friends will be impressed with all the work that you have on your page. Let's divide out the common factors in numerators and denominators. First, x minus 2 goes, leaving me with x plus 2 times 3. Distribute the 3 through. That gets us to 3x plus 6. In the second product, I can divide out the x plus 2's. That leaves me with x minus 2 times 1, which is just x minus 2. On the right-hand side, I can divide out the x minus 2's and the x plus 2's, leaving me with just 12. Let's simplify the left-hand side. Like terms, 3x plus x, that is 4x. Combine 6 and negative 2 to get positive 4. So we have 4x plus 4 equals 12. Now I can solve this for x by subtracting 4 from both sides of the equation. 4x equals 8. Divide both sides by 4, and we get x equals 2. But coming back to our LCM, I already wrote down that x could not equal 2 or negative 2. This solution of 2, this potential solution of 2, has to be omitted because it causes the least common multiple to be 0. It also causes the first and third fractions to have denominators of 0 as well. If I came back up here and put in the 2 in that first fraction, I've got 3 over 2 minus 2, or 3 over 0. That's undefined. That's not a solution. So the only potential solution I had was x equals 2. I've thrown that one out. That means that this equation has no solutions. Two more to go. Let's try this one. X over x plus 2 minus 2 over x plus 6 equals 8 over x squared plus 8x plus 12. So the first thing I'm going to do again is factor the trinomial, and it factors to be x plus 2 times x plus 6. And if I use the same approach for my LCM, that's going to be x plus 2 times x plus 6. Taking those first two denominators, notice the denominator on the right-hand side doesn't introduce any new factors. I also know that x cannot be negative 2 or negative 6. So if I find one of those as a solution, I have to throw that out. I'm going to multiply by the LCM, and I'm going to try to show you what I've seen some students do in terms of trying to write less. I'm just going to write that LCM in the numerator with each fraction. Right, so not rewriting the problem. I would divide out the x plus 2 in the first fraction. That leaves me x plus 6 times x. Distribute the x, and we get x squared plus 6x. In the second fraction, divide out the x plus 6's. I'm left with negative 2 times x plus 2. Distribute the negative 2 through. That's minus 2x and minus 4. On the right-hand side, both the x plus 2's and x plus 6's divide out, leaving me with just 8. I'm going to combine the two like terms on the left-hand side containing x. I'm also going to subtract 8 from both sides because I've got a quadratic equation and I want everything on one side equal to 0 on the other. That gets me to x squared plus 4x minus 12 equals 0. I can factor this. This factors to be x plus 6 times x minus 2 equals 0. And from there I get my two solutions. X equals negative 6 and x equals 2. And again, these are my potential solutions. I still have to check them. One quick note back on this line, although I use factoring to solve that, if you can't factor it, you're welcome to use quadratic formula, completing the square, whatever other technique that you prefer. But again, if you can factor it, you get those solutions a lot quicker. Up above, we mentioned that x cannot equal negative 6. I have to omit that first solution, but positive 2 is an okay solution. So my solution set is just 2. All right, 1 to go. This one's a little different. I've got 7 over x squared plus 19 over x equals 6. No factoring to do. The LCM is x squared. And x cannot equal 0 because when we said x squared equal to 0, the only solution is 0. So I'm going to multiply everything through by x squared. In the first fraction, dividing out the x squareds, that leaves me with just 7 plus x divided into x squared leaves x, so that's going to be plus 19x. Think of it this way. You have x times x on the top, you've got x on the bottom. Divide out one of those x's. On the right-hand side, that equals 6x squared. And so here, I've got a quadratic equation. I want to get everything on one side equal to 0. I'm going to subtract over the 7 and the 19x to join the 6x squared where it's positive. 0 equals 6x squared minus 19x minus 7. All right, so now we've got a decision. If you can't factor this quickly, then you should move on and use the quadratic formula. I'm going to actually do both ways here. This one factors to be, let's see, 2x times 3x minus 7 and plus 1. So if I can factor it within a short amount of time, you might have the 5-second rule, the 10-second rule. If the factoring comes to you quickly, you should. The benefit of this is if 2x minus 7 equals 0, 2x is equal to 7, x equals 7 halves. 3x plus 1 equals 0 means that 3x is negative 1, or x is negative 1/3. And I've got my two solutions pretty quickly there. Now let's take a look at what would happen with the quadratic formula. In the quadratic formula, we've got a is 6, b is negative 19, and c is negative 7. A quick reminder, the quadratic formula, x equals the opposite of b plus or minus square root b squared minus 4ac over 2a. In this problem, that's going to be x equals the opposite of negative 19 is 19, plus or minus square root b squared, that's negative 19 to the second power, minus 4ac, that's minus 4 times 6 times negative 7. And that's all going to be over 2a, which is 2 times 6. A little simplifying to do. Separate that out. X equals 19 plus or minus the square root. 19 squared, or negative 19 squared, that's 361. Negative 4 times 6 times negative 7, that's going to be positive 168. And that's all over 12. In the radicand, 361 plus 168 is 529 over 12. On our calculator, we could find that the square root of 529 is 23. So we have 19 plus or minus 23 over 12. 19 plus 23 over 12 is 42 over 12. Divide out the common factor of 6, that's 7/2. 19 minus 23 over 12 is negative 4 over 12. Divide out the common 4, that leaves us as negative 1/3. But notice that those two solutions were already here. So again, definitely an argument for factoring. This isn't the easiest one to factor though. When that leading coefficient is not 1, if the factoring doesn't jump at you right away, I recommend you play it safe and go to the quadratic formula, even if it's going to be riskier, right? More work. I think it ends up saving time in the long run. Our solutions, we were told at the very beginning that x could not equal 0. Whenever you have a factor that's a power of x, not x plus 5, not x minus 2, not 2x plus 3, just x squared, x cubed, the solution you have to omit is 0. And since neither of these solutions were 0, I'm going to put them in a solution set, negative 1/3, comma, 7/2. All right, that's it for rational equations. In the next video, we'll take a look at a couple of word problems involving rational equations.